Dark matter and its counterpart, dark energy, are the oft-cited Achilles heel of standard cosmology. Not that you would know it if you take your understanding of the universe from popular science shows. In that world, they are usually presented as established fact. It is as if the case were closed and their existence beyond reasonable doubt. In reality, dark matter and dark energy are not established facts. They are speculative constructs, mathematical inventions designed to keep deeply flawed models alive. After more than 4 decades of searching, both remain elusive and undetected. They are undetectable by any current instruments, optically inert, producing no scattering or shadows, exhibiting no electrical or magnetic properties, and generating no friction. Their distribution is arbitrarily assigned wherever it is required to reconcile observations with theoretical expectations. Dark matter thus functions as a convenient theoretical construct. That's a polite way of saying fudge factor, of course, allowing anomalies to be absorbed through precisely tuned exceptions rather than prompting a reassessment of the underlying theory. Without this construct, proponents would be forced to concede that the theory itself has been falsified. This reliance on exotic hypotheticals reveals a deeper problem. Detectable phenomena comprise less than 5% of the cosmos described by the Standard Model. Over 95% of the universe exists solely by the insistence of theory and the fervency of its proponents' belief. History offers a cautionary tale. Astronomers once assumed that darkness in the Milky Way signified emptiness, until improved instruments revealed dense clouds of gas and dust obscuring the light beyond. Nobel laureate Jim Peebles put it bluntly, quote, "It is an embarrassment that the dominant forms of matter in the universe remain hypothetical." End quote. The problem that gave rise to dark matter was not mysterious substance but anomalous motion. Stars in the outer regions of spiral galaxies orbit at nearly the same speeds as those closer to the centre, contrary to the expectations of unmodified gravitational theory. Likewise, galaxies within the clusters move so rapidly that, according to standard calculations, the clusters should disperse far faster than their supposed ages allow. When astronomers first observed galactic rotation curves, something clearly didn't add up. The stars on the outer edges were moving too fast, far faster than visible mass alone could account for. According to conventional gravitational theory, such galaxies should be flying apart. Rather than re-examining the assumptions about gravity itself or considering other long-range forces, cosmologists inserted an invisible form of mass to make the equations work. This was dark matter. Unseen, undetected, yet conveniently distributed wherever gravitational theory broke down. The Standard Model asserts that if observed motions do not match gravitational expectations, then dark matter must be present. The assumption justifies the conclusion, and the conclusion reaffirms the assumption. It is a tautology dressed as science, circular reasoning no less. As Saul Perlmutter acknowledged, quote, "The universe is made mostly of dark matter and dark energy, and we don't know what either of them is." End quote. Dark energy soon followed dark matter, introduced to explain the accelerating expansion of the universe. Here again, instead of modifying the model or questioning the interpretation of redshift data, theorists added another invisible component, one that now accounts for nearly 70% of the universe in the standard framework. Quote, "Dark matter and dark energy are the blank checks required to postpone the falsification of bankrupt theories." End quote. Thunderbolts project. In plasma cosmology, these theoretical patches are unnecessary. This alternative approach, rooted in the work of Nobel laureate Hannes Alfvén and further developed by Anthony Peratt at Los Alamos National Laboratory, recognizes that plasma and electromagnetism, not gravity alone, dominated the behavior of matter in space. Quote, "The plasma universe is not a figment of theoretical imagination, but a natural consequence of the known properties of matter in the plasma state," end quote, Hannes Alfvén. Plasma is not merely an ionized gas, but a distinct state of matter. While transitional phases exist, fully developed plasma is characterized by collective behavior, with charged particles acting coherently through electric and magnetic fields. In this regime, long-range electromagnetic interactions dominate, giving rise to filaments, currents, double layers and self-organizing structures unknown in neutral gas or dust. Plasma constitutes over 99.9% of the visible universe, and within it, electromagnetic forces, some 10 to the power of 39 times stronger than gravity, play a decisive role in shaping cosmic structure. Quote, "Electricity and magnetism are ignored in astrophysical models at peril. The electromagnetic force is vastly stronger than gravity and can organize plasma across cosmic scales," end quote, Anthony Peratt. Plasma-based models reproduce galactic rotation curves, filamentary structures, and intergalactic dynamics without resorting to exotic matter or mysterious energy. Peratt's computer simulations of colliding plasma clouds, for example, produced spiral galaxy morphologies and flat rotation curves using only well-established electromagnetic principles. At the heart of the issue lies a foundational assumption that gravity scales universally with mass in the same way at all distances. Yet there is no guarantee that this relationship holds on galactic or cosmic scales. What if other forces dominate instead? Standard cosmology largely dismisses electromagnetism as a meaningful agent in cosmic structure. Plasma and its electromagnetic interactions are sidelined not because the evidence is weak, but because they cannot be accommodated within the prevailing gravitational framework. Yet in laboratories and in direct observations of space plasmas, from the sun's corona to the tails of comets, plasma behavior is governed overwhelmingly by electromagnetism, not gravity. On cosmic scales, where plasma is ubiquitous, these effects are not peripheral, they may be decisive. As Alfvén emphasized, quote, "In order to understand the phenomena in a certain plasma region, it is necessary to map not only the magnetic, but also the electric field and the electric currents. Space is filled with a network of currents which transfer energy and momentum over large or very large distances." End quote. He was characteristically blunt in his 1970 Nobel lecture. Quote, "The cosmical plasma physics of today is far less advanced than laboratory plasma physics. The reason is that astrophysicists have not learned plasma physics." End quote. Dark matter is often described as non-baryonic, that is, not composed of ordinary particles such as protons and neutrons, but of something altogether more mysterious. Yet, if it possesses mass, what gives rise to that mass? What structure supports it? In particle physics, the Higgs boson, the so-called God particle, was proposed to explain why particles have mass. Conceived by Peter Higgs in the 1960s, it shares several traits with dark matter. It is massive, electrically neutral, and very difficult to pin down under normal conditions. The Large Hadron Collider at CERN announced its, quote, discovery in July 2012 with great fanfare. Yet conflicting data, unexplained results, and ongoing uncertainty continue to cloud the particle's status. Quote, "We do not see the signal. If it existed, we would see it. But when we look at our data, we basically see nothing." End quote, Dmitry Denisov. Even after upgrades, the particle stubbornly refused to behave as expected, as New Scientist later observed. Quote, physicists have spotted the Higgs boson performing a new trick, but one that brings us no closer to understanding the workings of the fundamental particle. End quote. Leah Crane. One is left to wonder whether a particle imagined to explain mass is any more tangible than the dark matter imagined to explain gravity. Astronomers once believed the Coalsack Nebula was a great cosmic void, until better instruments revealed it as a dense cloud of gas and dust, obscuring the stars beyond. Darkness, it turned out, was not emptiness. Today, we may be repeating the same mistake on a far larger scale. Modern instruments are uncovering vast reservoirs of atomic and molecular hydrogen, interstellar dust and cosmic plasma, the overlooked substance of the universe. These media, largely invisible to optical telescopes, now demand inclusion in any serious cosmological model. In 2011, reports on radio observations of the galaxy 3C303 described something striking. Evidence consistent with an immense current associated with a large-scale astrophysical jet. Quote, a cosmic jet 2 billion light-years away is carrying the highest electric current ever seen, 10 to the power of 18 amps, equivalent to 1 trillion bolts of lightning. End quote. Popular Science, 2011. Whether one accepts the electric current language or prefers the safer phrasing of electromagnetic energy flow, the underlying point remains. Radio data repeatedly reveal a filamentary, structured universe, one in which plasma dynamics and electromagnetic fields are not decorative details, but central actors. Indeed, the original paper inferred a galactic scale current of order 3 times 10 to the power of 18 amps for a segment of the jet, and argued that the jet's energy flow is mainly electromagnetic. Radio observations, in short, keep dragging cosmology from imagined voids toward electrically active structure. Peratt puts it like this, quote, space is filled with plasma, not empty vacuum. This plasma carries currents, generates magnetic fields, and interacts dynamically with matter and radiation. End quote. In recent years, a subtle but consequential sleight of hand has become increasingly common in cosmological presentations. Filamentary structures in the universe, long thread-like formations that make up the so-called cosmic web, are directly observed in galaxy surveys and large-scale structure studies. These same structures are also detected through radio, X-ray and synchrotron observations of galaxy clusters and the intergalactic medium. Yet they are frequently converted to greyscale, stripped of their electromagnetic context, and represented as maps of dark matter. What began as a modelling convenience has quietly become a post hoc reinterpretation. Structures that are directly observed, braided filaments and current-carrying networks characteristic of plasma, are relabeled as gravitational scaffolding for invisible matter. The same filamentary patterns, once identified as plasma or ionised gas, are rebranded as dark, simply by removing colour, wavelength information, and physical attribution. This interpretive move is now routine. For example, as Astronomy.com reported in 2021, quote, astronomers using the NASA ESA Hubble Space Telescope have studied a giant filament of dark matter in 3D for the first time. End quote. Describing a structure extending 60 million light-years as part of the cosmic web that shapes large-scale cosmic structure. The logic is circular. Filamentary structure is observed. The model requires dark matter to explain structure formation. Therefore, the filaments are declared to be dark matter. Even when identical patterns arise in directly observable plasma, the label is supplied by theory, not by evidence. In laboratory plasma physics, filamentation is immediately recognized as a signature of electric currents and collective electromagnetic behavior. Only in cosmology is the same phenomenon routinely redefined as the effect of an undetectable substance that cannot be measured, sampled, or independently verified. The universe has not grown darker. Our interpretations have. Dark matter, dark energy, the Higgs boson. Each is a critical card in the modern cosmological edifice, theoretical constructs that serve the model yet defy direct detection. Together, they uphold a worldview increasingly disconnected from observation, but one in which vast intellectual and financial capital has been invested. What happens when these cards collapse? Quote, "The cosmic theatre has outgrown the Newtonian stage. Instead of a vision of isolated bodies turning gear-like in a vacuum, we need a vision of electrical circuits embedded in a conducting medium. We have entered a world of plasma where the rules are different and more complex. We now live in an electric universe." End quote. Thunderbolts project. Perhaps it is time to stop adding ghosts to the machine and start listening to the electric heartbeat of the universe. In the next episode of this Misconception series, we will take a look at another common question. Why electricity over magnetism?